Okay, looking at the 2018 BC number 6, the series question, they give you the series for the natural log of 1 plus x, and then they tell you that f of x is x times the natural log of 1 plus x over 3, and they start off by asking you to write the first four non-zero terms for f. And so I'm looking at f, and I'm looking at how it compares to the series that was provided, and I noticed two things. They multiplied by an x, and in the place of x, they put an x over 3. So I'm going to do this in two phases. I'm first going to write the series for the natural log of 1 plus x over 3. And to do that, I'm just going to replace every x in the given series with an x over 3. So that's going to be x over 3 minus x over 3 squared over 2 plus x over 3 cubed over 4. And that, wait a minute. Yeah, that's right. Minus x over 3 to the fourth over 4. There was my mistake. I knew I made a mistake somewhere. This is over 3. There. And then for the general term, same thing. Negative 1 to the n plus 1, x over 3 to the n, all over n. And I'm debating cleaning that up. I'm not yet. So what I'm going to do now, I'm going to write the series for f of x, which is x times the natural log of 1 plus x over 3, which means I will just multiply this whole series right here that I just wrote by an x. So if I multiply that by x, and then if I distribute an x through this side, I will have the series for x ln 1 plus x over 3. So that will be x times x over 3 is x squared over 3. And for the rest of them, I think I'm going to keep it simple for now. I'm just going to do x times x over 3 squared over 2 plus x times x over 3 cubed over 3 minus x times x over 3 to the fourth over 4 plus, and then for the general term, I'm going to do the exact same thing. I'm going to leave negative 1 to the n plus 1, and then x times x over 3 to the n, all over n. And there is my series for f of x. It would simplify, but I'm just going to leave it like that for now, and I will tackle the simplifying if I need to for a later part. Part B asks you to find the interval of convergence, so we will have to test the endpoints. So the interval of convergence for this series f. So at this point, I'm going to simplify the general term, because the general term is what I will use in the ratio test. So we'll use ratio test in B. So my general term is negative 1 to the n plus 1. X times x over 3 to the n would be x to the n plus 1. And that 3 to the n, I'm going to move to the denominator with the n that is already there. And that series would start at, and I'm just looking, my first term is x squared. So to get an x squared, I need to plug in a 1 for n. And if I check that everywhere else, so that is correct. So I'm going to start with n equals 1. And then the ratio test, limit as n goes to infinity of the n plus first term, negative 1 to the n plus 2, x to the n plus 2, all over n plus 1, 3 to the n plus 1, times the reciprocal of the original, n times 3 to the n, negative 1, n plus 1, x, n plus 1. And start canceling. So see, I have one more 3 on bottom. I have one more x on top. The negative ones, yeah, technically there is one negative 1 in the numerator, but the absolute value of that will turn it into positive 1, so we're not going to worry about the negative. That leaves me with limit n goes to infinity of n absolute x times n. The negative 1 becomes positive when you absolute value it. And then in the denominator, 3 and n plus 1 are already positive. So I'll leave it like that. And when you find the answer to that limit, you do get absolute value of x over 3. And then to finish up with the ratio test, I'll move my head down here. We need that answer to the limit to be less than 1. So I need absolute x over 3 to be less than 1, would give me absolute x is less than 3. So there's my radius, which then gives me the interval, -3 to 3. And now we need to test each of those endpoints to determine whether we converge at the negative and positive 3. So I'm going to test x equals -3. And for x equals -3, I would have the series plugging in -3 right here. I would have -1 to the n plus 1, -3 to the n plus 1, all over n times 3 to the n. And let's see what happens here. Let's see. Oh, geez. So the -1 to the n plus 1, I'll just leave like that. I have another -1 to the n plus 1. And then a 3 to the n plus 1. And I wanted to separate out the negative and the 3. In the denominator, I have that n times 3 to the n. And now I'm going to start reducing 3 to the n plus 1 and 3 to the n. I will have a 3 left over in the numerator. -1 to the n plus 1 times -1 to the n plus 1. That, you can look at that in a couple of different ways. I'm going to add those exponents. That's the same thing as -1 to the 2n plus 2. And 2n plus 2 will always be even, and -1 to an even power will always be 1. And so this series ultimately simplifies to 3 over n, which will diverge by the p-series test. P-series. So we diverge at -3. Now we need to test x equals +3. And so if I plug in 3 for x, I'll have -1 to the n plus 1 times 3 to the n plus 1 over n 3 to the n. There is one more 3 on top and nothing else reduces. So we end up with the alternating series of 3, whoops, -1 to the n plus 1. Uh-oh, I lost my, there it is, okay. Move that 3 over. That times 3 all over n. And we are going from 1 to infinity. And so this is an alternating series. I know it's going to converge, but because this is a free response question, I feel better if I show explicitly that it converges. So first, I'm going to make a note that it does alternate. The terms, if you ignore the alternating aspect, the limit as n goes to infinity of 3 over n is equal to 0. So that's the first condition for the alternating series test. And we need to show that it decreases. Is the n plus first term always less than the nth term? And if you plug in n plus 1, 3 over n plus 1 is indeed less than 3 over n. That is true. Therefore, this converges. There we go. Converges for x equals 3, which gives me my interval of convergence as we did not include the -3. We will include the +3, and there is your interval of convergence for part B. Wow, that was a beast. Okay, let's move on to part C. So we have the 4th degree Taylor polynomial for f about 0, which would be these first 4 terms right here. And I think I'm going to grab that really quick. I say really quick. Let's see, view, screen capture. Hold on. So I'm going to grab f of x, just the first 4 terms, which is that. Let's just copy that. Copy over and paste. Close U. That's not what I wanted to do. Okay, so there is my 4th degree Taylor polynomial. Use the alternating series error test to find an upper bound for that. And this expression, the Taylor polynomial at 2 minus the function's value at 2 is the error. error in using the Taylor polynomial to estimate the function's values. And the upper bound for an alternating series test is the first omitted term. So I actually need to find my fifth term when I plug in 2. So f of 2, according to this polynomial, would be approximately 2 squared over 3 minus 2 times 2/3 squared over 2 plus 2 times 2/3 cubed over 3 minus 2 times 2/3 to the 4th over 4. And if I add those, I will get my Taylor approximation for f of 2. And the error is less than your first omitted term. So now I need to find my next term. And following the pattern, it's going to be 2 times 2/3 to the 5th over 5. And that is my first omitted term. That says omitted. That's my first omitted term. And one thing that we need to include in our writing is that this is a convergent alternating series, and we are within the interval of convergence. So that's something else to consider. We are plugging in 2, and my interval of convergence was all that work from part B, -3 to 3. So we are within the interval of convergence. So the maximum error in a convergent alternating series is less than the magnitude of the first omitted term. And in this case, that first omitted term was 2 times 2/3 to the 5th over 5. They did not ask us for any, that is a jacked up 5. They did not ask us for any interpretation of this. They didn't say, show that this is less than 1 over 1,000 or something like that. They just asked for an upper bound for that error. And while I cannot really wrap my head around that value, that does answer the question. So I feel happy with my answer to part C, and I'm done.